Hello, this is Group 5. My name is Jonathan Garris, and we are going over engineering ethics.
My name's Killian.
My name is Juan.
My name is Rico.
My name is Giovanni.
So, in this presentation, we're going over the introduction, which covers what exactly is engineering ethics. In part two, we go over the case studies of ethical failures, and then in part three, we go over the modern ethical challenges. In section four, we go over the ethical decisions slash making models for engineering ethics. And in the last part, we go over the global perspective of engineering ethics. So, what are engineering ethics? Engineering ethics is a field of study and practice that focuses on the moral obligations and professional responsibilities of engineers. To ensure public safety, engineers must think about how a product or design will impact the public and the potential consequences of it. So, it really comes down to asking, how is my design going to affect others? And what can I do to ensure that no one gets hurt? Our work can have a huge impact on the lives of other people. Sometimes it's just that one small mistake where we think no one's actually going to do XYZ, but then someone does that. Someone does XYZ. So, as engineers, it's our job to think ahead and think, how can we make sure the things we design are safe, reliable, and ready for public use? So, what codes of ethics do we follow? As electrical engineers and those related to the field, such as computer science majors and computer engineering majors, one of the most relevant organizations to our profession is the IEEE, or the Institute of Electronic and Electrical Engineers, which defines the ethics we should strive to follow as one, upholding the highest standards of integrity. We can uphold a standard of integrity by doing the right thing, even in difficult situations, by owning up to mistakes and being clear on what we can and cannot do, such as cutting corners or taking bribes. People trust engineers to build and design products to be safe and reliable, but that type of trust can only come with transparency. Two, to treat all people fairly and with respect, as well as avoiding the injury of others. As engineers, we're expected to treat everyone with respect, no matter their background, identity, or their beliefs. Part of treating people with respect is to make sure we don't harm someone's reputation or job through false claims or careless behavior. And finally, the last point, we have to ensure that this code is being upheld by other engineers. When we hold others accountable, we're also keeping ourselves in check. It's not about pointing fingers, but rather it's about making sure that our work is safe and ethical. Everyone who comes in contact with our designs depends on us to get it right. And other engineering societies, such as the American Society of Civil Engineers or the National Society of Professional Engineers, they also have a very similar set of ethics, which further highlights the importance of ensuring the safety of others that engineers must consider when designing. And finally, why do we need ethics codes? Engineers need codes of ethics because our designs directly affect the public, and not always in positive ways. Companies may try to cut costs by using lower quality materials, which can lead to safety risks. It is the engineer's moral responsibility to stand up for public safety and ensure that their work meets professional and ethical standards. Part of being a good engineer is realizing that what we do is a service to the general public. By recognizing that and upholding ourselves and our peers accountable, we can produce quality work with clear safety guidelines.
Okay, so I'll be talking about a case study of a real-world example of what happens when um, there's an ethical failure in engineering, and explain what happened, how it happened, um, how we dealt with it after, what are some of the lessons that we learned from this. So I decided to choose the Surfside condominium collapse. A couple reasons. One, it happened not too long ago, and it also happened locally here in Miami. And it's important to note that even with all these laws and regulations that we have in place nowadays, these things still happen. And so this happened in 2021, and it was a partial building collapse, meaning about half the building collapsed. And as you can see in the timeline, it was built in 1981. There was an inspection report done in 2018, and in 2021, of course, is when the building collapsed. So what went wrong technically? In the report, so every 40 years you have to have the building recertified, meaning inspections have to be done and regarding the structural integrity of the building. And there's quite a few notable things that are reported. The major one is that there was extensive damage in the structural pillars in the parking garage. There are a lot of areas where the concrete was just broken off. And as you can see in the figures, some of the concrete was exposed to rebar inside of it, and that rebar was corroded. So that was, of course, that's alarm bell should have been ringing because that, of course, is a safety issue. And also in the pool deck area, the waterproofing failed, meaning that the water was intruding into the building itself, and that was probably the cause of why the rebar is corroding, affecting the concrete as well. And also, when the building was first built, the pool deck area was also not sloped. It's supposed to be sloped so water drains away from the building, but it was built flat so that the water stayed. And when water stays, it tends to intrude into areas it's not supposed to go to. And that might have been also a cause. It's still under investigation. It's going to take some time, but these are some of the things that they found and probable causes of why the building collapsed. So what were some ethical failures that occurred? Well, for one thing, it took 2 years for the association to start any sort of repair work based on that report in 2018. And there was just no sense of urgency. The report didn't specifically state any urgency in these when they saw these cracks in the foundation, and there was some back and forth between the association and the unit owners because the total cost in 2018 to do these repairs came out to $9 million. And then after 2 years, it went to 12 million. So basically, every person that's living in a unit had to pitch in about $100,000 to do these repairs. And of course, that's a lot of money for a lot of people. And they kind of were dragging their feet because of that. And so that was a failure on the part of the people living there and the people running the high rise. There was a lack of communication between the association, the people living there, and the city officials. And basically, they put money over the safety. And in that case, this is what can happen when these things occur. So what were some of the consequences? Of course, the loss of life is the most important one. There was a lot of legal actions, of course. About $1 billion worth of lawsuits have been handed out, to the families of the unit owners and to other parties. And also, there was a mandatory inspection now for high rises that are more than 3 stories high. And in those mandatory inspections, of course, a lot of buildings found out that they also needed repair work done. And so now all the other buildings in the state of Florida that need to have those repairs, the people living there have to pay for it. And it's thousands of dollars, sometimes $20,000, $30,000. And now all of a sudden they have to pay out of pocket for that, where before maybe they didn't have to, or maybe they didn't have to do it so soon. And also there's a loss of trust in these older buildings now. Obviously there's a fear factor of more buildings collapsing. So less people are willing to live in these similar types of buildings. So the price of the property went down. And if you're trying to sell, let's say, a high-rise unit, it's very difficult right now to do that. I know a family member who is trying to sell a unit right now, and she initially listed it for $132,000, and now it's down to $96,000, and still nobody wants to buy. So it's very difficult, and the insurance premiums are going up, and also the maintenance fees are going up too, because now all these repairs have to be done all of a sudden. So what are some of the lessons learned? Well, there needs to be better communication moving forward. The association needs to create more urgency when repairs need to be done, and the city officials need to be notified of these things so that if people start dragging their feet, then something can be done about it. The inspections have to be more thorough, and reporting has to be done more frequently. Maybe 40 years is too long of a period in between these mandatory recertifications. And it's important to follow proper procedure. You know, if you're an engineer and you see that your boss is cutting corners when building something, maybe you should talk to him, or maybe you should report it to the city, because at the end of the day, you put money over safety, and that's when these things can happen. So how did things change? So first, there's revised building codes, and there was a bill that was passed that now, 30 years after the construction of a new building that's above 3 stories, you have to have a mandatory inspection. And then every 10 years after that, you also have to have another mandatory inspection. That was not the case beforehand. And now in the state of Florida, every high rise has to have those inspections. And also, there's now a mandatory reserve. So there has to be money set aside now in case of future repairs. And there has to be a report done of what those future repairs might be and how much money will have to be set aside. Before this, it was not mandatory. Associations could ask or put to vote if the unit owners would like to have a reserve or not. But now it is mandatory for high rises above three stories or more, and that also leads to an increase in costs living in this sort of a high-rise building. So there are many changes that happened, and hopefully something like this doesn't happen in the future.
I'll be presenting on emerging ethical challenges in modern engineering. As engineering continues to evolve rapidly, it touches on critical fields like AI, biotechnology, autonomous vehicles, and cybersecurity. What makes it so important is that engineers today don't just build tools, they shape systems that impact millions of lives. But while technology races ahead, ethical frameworks often lag behind, which creates serious questions and challenges that needs to be addressed. First, AI faces major ethical concerns in transparency, privacy, and trust. Fake transparency. AI systems often are black box where even developers can't explain why certain decisions happen. A tragic example of this is back in 2018 and 2019, a Boeing 737 MAX 8 crash since an AI software overrode the pilot due to poor system transparency. In terms of privacy, AI often processes huge amounts of user data without clear control or consent, raising ethical issues about data and ownership and manipulation. And then there's trust. People either overly trust AI or don't trust it at all, which can be an issue since most ethical guidelines in AI are still too vague and rarely enforced. Biotechnology adds its own challenges. First, data privacy. AI and biotech handles very sensitive data, like genetics or health records. If misused or leaked, it can have serious consequences. So strong regulation and transparency are crucial. Also, algorithm biases in biotech AI can lead to misdiagnosis or unequal access to treatment, especially in underrepresented groups. This raises questions of fairness and equity in healthcare. Autonomous vehicles slash AVs bring new moral dilemmas, especially in life or death situations. For example, should a self-driving car choose to harm one person or many if a crash is unavoidable? AVs often apply utilitarian logic, choosing the outcome with fewer casualties, but human ethics see all life as equal. There's also a lack of legal and ethical standards for these decisions. Plus, AVs are vulnerable to cyber attacks like Yandex and Tesla breach, where hackers were able to take control of um, various AVs, where they will be able to control the vehicle as well as unlock the vehicle. which showed how easily these systems can be hijacked, putting public safety at risk. Lastly, the AV industry often ignores core ethics like fairness, justice, or responsible innovation, highlighting the need for strong oversight and regulation. Cybersecurity deals with its own ongoing ethical challenges. Some examples are a data breach, which can violate trust and cause huge damage to people and businesses. Cyber attacks, which can destroy infrastructure, damage property, and cost millions. There's also a constant tension between security versus business, which is like when updates or patches are delayed to avoid downtime, even if it leaves systems vulnerable. There's also transparency, which is vital. Companies must clearly communicate how they use data and report breaches honestly to earn trust and stay accountable. In choosing as In closing, as engineers, we are not just solving technical problems, we're making ethical decisions with real world consequences. That's why it's more important than ever to integrate ethics into every stage of design and development. And as years to come, there will always be challenges that we need to address or needed to be addressed.
All right, so today I'm going to be talking about ethical decision-making models for engineers. So basically what going to talk about today is just navigating the dilemmas with responsibility and integrity. So understanding ethical decision-making models in engineering. Why does it matter? So engineers, including all of us here, we face real-world problems with high risk. So it could be involving, like we said previously, human life, infrastructure, or anything. We have a big job, it comes with a big risk. And we need to ensure ethics obviously ensures public safety, trust, and professional integrity. And overall, decisions are always black and white. So even though we may see something and say, "Oh, it's there, it's so easy, I'm gonna make this decision." Like I always say, every action has a consequence. So we may make the right decision or the wrong decision. We may never know until we implement it, and then there's our risk. So ethical frameworks for engineers. So some core ethical frameworks to use are utilitarianism, sorry, duty ethics, or formerly known as deontology. And we have our National Society of Professional Engineers decision-making model. But one thing you notice that I don't have virtue ethics in bullet is because doing what is morally good for the people is a hard thing to do. Because we say with money, the cost of this and that, and if it's really worth it, if people be all right, we could make a cheap building with cheap material. Oh, it'll last for a couple years. Somebody's grandma, probably 80 years old, she goes into a new condo that was built with cheap material. Oh, she might not even live to even last it, but that's not the mindset to have as an engineer. We have to set ourselves in a good standard to saying, okay, we're here to make people lives. Engineers before us, way before us, built things to last. So why can't we? Why can't we do good for the people? Why can't we do this and that? Why is it different? So the National Society of Professional Engineers 9 steps to ethical decisions are just a formal because every state, including Florida, we have our own steps to ethical decisions, but the NSPE is just the standard. So the first step is to stop and think. You never want to rush into a decision and say, boom, I got the answer. There it is. You need to sometimes to stop, breathe, and just think. Because if you're rushing stuff, you're gonna make mistakes. And mistakes happen, of course, but it could be costly. Second is to clarify your goals. Just make sure everything is dotted out, T's, X's, Y's, everything, because you just want to make sure everybody's on the same page as a team. The third is to determine the facts known and unknown. You find out everything known and unknown, and you sit down and you fact check it. You make sure everything's right. And four is develop options. You don't always want to go with your plan A, but you always have a plan B and C. Your plan A is, okay, this is my plan. I'm going to stick with it no matter what. But you always want a plan B and C in case plan A fails. But the goal is for your plan A to never fail, but always have a backup plan, no matter what. 5 is consider foreseeable results of options. Like I said, this could be as a team, you could develop your options and somebody else may have a different opinion. Okay, we can use these options, So make sure you guys always communicate and say, okay, these are the options that we have together. And 6 is refers to the NSPE ethic resources. So at the end of this slideshow, you'll see resources to go and view this link and you view all the ethical decisions and their facts and their notes about making decisions in engineering, whatever major you're in, electrical, CSC, etc. It's there. 7 is referred to state registration law for guidance. So Florida, I think Florida has a administration, I think it's chapter, if you refer to Florida's administrative law chapter 471, you'll see our requirements for, what they expect out of us. And number 8 is consult with respective staff or outside professionals. So it could be like us, we would result to like a professor or somebody that's well respected in our major or in our profession. So we always want to do that just to get everybody's insight because everybody's opinion matters. And 9 is decide a course of action and take it. You make your decision, you go through all these steps and stuff, and you say, okay, whatever my decision is, I'm going to make it right now, and I'm going to take it. And we at FAU, we know Perry. This is a favorite scenario about the bridge that happened in the FIU. So a pedestrian bridge under construction at FIU collapsed on March 15, 2018. 6 people were killed and several were injured when the bridge fell onto traffic. So what went wrong? So structural cracks were observed days before, but dismissed as non-critical. They seen a couple cracks and, people just kept on working. And there was poor communication between the engineers, contractors, and city officials. It was a big construction job and the roads weren't closed and the bridge literally oversees traffic, oversees the highway. And, there were no roads closed off, no anything. They were just working like nothing, like it wasn't a big project. And no urgent decision to close the roads or pause construction. Even though people came, inspected this and that, everybody just went along like it's fine. But the questions that I want you guys to ask yourself, ladies and gentlemen, is did the engineers act accordingly, which is obviously not? And how might the NSPE steps apply to the situation? And would performing virtue ethics present different actions? So I just want you to think about this and ask yourself, if you were an engineer at that site, what would you do to prevent this from happening? Because even though we may say we could do this and that, we can't go back in the past and change it. We just got to learn from
it. Importance of cultural and ethical diversity in global engineering practice. So as engineers start to work across borders, understanding cultural and ethical diversity becomes essential. First, diverse cultural norms means that each society has its own set of values that influence how engineers are expected to act ethically. What's seen as acceptable in one country might be problematic in another. For example, data privacy. In some countries like China and Russia, mass data collection on users is common, while in the contrary, places like Europe, that behavior can be seen as a major breach of ethical standards. A different example is direct or indirect communication. So here in the US, people are encouraged to express their opinion and provide their feedback openly. But in places like Japan or Korea, indirect communication is preferred. In these cultures, direct criticism may be considered rude or even disrespectful. Next, global collaboration challenges arise because societal expectations are different. This can affect how professionalism make decisions when doing their responsibilities. Engineers need to be culturally aware. In some countries like China and Russia, mass data collection on users is common and stay mandated. Okay, second slide. So when talking about climate engineering, there are ethical dilemmas that arise, especially the risk that is associated with manipulating the climate. In an article by Gardner's, it says that climate engineers is not merely a technical challenge, it is a moral one. Altering global system can have environmental effects. We can also have social and political dilemmas. For example, who decides what is the ideal global temperature, or how can we ensure that the wealthier nations do not dominate these decisions, potentially harming vulnerable regions. Climate engineering forces us to reconsider what true international cooperation should look like. All right, there's that. All right, since artificial intelligence is becoming more integrated into our daily lives, the necessity for an ethical and global regulation is growing. Some countries are now placing a stronger emphasis on the ethical implications of AI. There is an article that was published in 2004 by Calvo and Peters. They say that countries are becoming more and more different in how they regulate these technologies, such as autonomous vehicles and even AI weapons. Each country has their unique ethical priorities and safety concerns. For example, some countries may prioritize economic competitiveness or national security, while others place a higher priority on data privacy. Or slide. Global competency is a major focus on engineering education. So a study from Springer highlights that today's engineering programs aid to prepare engineers to work across cultures, considering different ethical views, and think critically about how their work affects society. By doing this, programs make sure that engineers not only become skilled professionals, but also socially responsible leaders. All right, next slide. All right, this is going to be the slide for the to learn more about engineering ethics. And these are the reference page. Next slide. All right, next slide.
I think that's it.
All right, that's gonna be
Yeah.
all.
So
All right, cut that. We'll have to cut that down.